Okay. Hi, welcome everyone to today's webinar sponsored by DataMites. And we have a speaker for the day is Kulin Patel. He's an industry expert, lecturer, and at the Bath Spa University Academic Center. He's a keynote speaker and mentor who's helping companies getting started with artificial intelligence and in building teams for AI implementation. He's an artificial intelligence engineer at Doctor on Click, Singapore, and he's also an industry expert at the Bath Spa University Academic Center in UAE. Over to you, Kulin.
Hi everyone. I hope everyone is fine in this COVID era and healthy. You and your family. Let us begin this seminar. This topic is how machine learn to interpret images. So first of all, before we go into how machine learns in the images, we first have to have basic understanding of the images and pixels. Let's see. Images. What images are represented in RGB format? 3 color channels, and each pixels have the value of the 0 to 255. I'll be showing you the images so you can have a clear look. So this is the image, and the arrow points to 1 pixel, and each pixel has 3 values. First value is for the red color, and second is for green color and the blue color. The image, all the images have the pixels, and pixels have 3 values if it's a color image. And color codes are like this. You can refer later for the red, yellow, and magenta, blue, cyan, green. And for example, let's to understand the images and more the point of view computer vision, we will take example from for the grayscale image, because it will be easier for us to understand. So from the left hand side, you can see the one image, and each image have the value. Like these images, 1 pixel has 157 value. So the in grayscale, the value from 0 to 255 varies from 0 to 255. So this is another example. All the images pixels have the value corresponding to it. If it's black, it will have a value of 0, and if it's white, it will have a 255 value. And all the in between are the gray. 0 is black, 255 is white, and the black. Yes, here is how it shows. 51, 102. It becomes brighter when you go towards 255, value of 255. Then before we go into the deep learning and how images learn, we should have some basic knowledge of machine learning and deep learning. How does the machine learning works? So we give input to the machines that this is the car. Then the machine will extract the features, and then it will classify it if it's a car or not, bus, what is it. And in a deep learning, it is like a black box. What happens inside, we don't know, but it tries a permutation and combination inside, and then gives us output. So from the point of view from the computer vision and image analysis, this is the number of 8, how it looks like in values. Then for the computer vision with a deep learning, so first of all, we have to extract the features from the images. Like this is the dog, but dog has the ear. So somehow we feed the dog a picture of dog in a convolution layer or the deep learning algorithm. Then it will understand eventually, not if you give a large amount of data, lots of thousands of images, it will understand these parts is like image has eye and ears and and nose and legs and all the things. These are called the features, and we have to first extract the features and then classify into the if it's a dog or cat, mango or banana. We have also seen some like image styling. So we have, if we input this image, the house, and the style reference, it will learn from the style reference, there are curves and blue colors, and these are the features of this style. So it will implement this style in this house picture and gives us the output of the combination of the image. So it the blue image has small features that it learns from the machine learning, and then it implements the original image and then give us the output of the image. And we have seen the applications like the Prisma few years back. It was a viral application. So now the computer vision has gone beyond this. So first, computer vision, and with the deep learning, first we will have to understand the three or four terminologies. What is the convolutional neurals? What is max pooling? Flattening the image. So before that, what is the kernel? I'll show you. So let's take example from this image. The kernel is at the middle part, 3 by 3 kernel. We multiply this kernel to the image pixels from the violet part. Corresponding to it, first we will multiply the 0 and 0, then multiply with 0 and -1, and gives us the output at bottom. You can see I have highlighted. Then all like 6, and we get the total of 320. So this is the we have multiplied this kernel into the 3 by 3 kernel to the 3 by 3 pixels in the images. In another type of visualization, we can do this the filter is the kernel. So we multiply with 9 and 0, then 4 and 2, this 1 and 1, then we get we uh, add it, and we have the answer of 16. So this is how actual process looks like in red, green and blue. If we have three images, we get the corresponding output here at the bottom in yellow color. Kernel moves from left to right in the images. The above part, this large part is the image. I have separated this in red, green and blue channels. So this is the basic maths. We add it here, and this we don't have to do it manually. We have the algorithms and one line of code, and you can do it. Then comes the another part, called the max pooling. In max pooling, what happens? We extract the maximum value of that pixel. This is the value 12, 20, 12, and 8. So what is the maximum number of these four pixel? 20. So we put 20 value here in output. 2 by 2 maximum pool, max pool. Then there is another term of flattening the image. So what is the image? Image is a 3 by, here in an example, 3 by 3 image is there, and if we flatten it, we organize in a vertical line, or we can say a 9 by 1 vector. 1 1 0 1 1 0, 4 2 1, 4 2 1 here, and 0 2 1. So this is the flattening of the image. Mhm. Yes, we have seen. Can you see my another tab I have shared? Can someone answer?
Yeah, Colin, we can see what you just showed. Yeah, we can see one in blue and one in green.
Okay. So I have gathered some visualization, and I'll be sending you this PPT so you can have these links and play a little bit. So this is the one image, and I want to apply the filter to it. So if I want a vertical edge out of it, so I'll use this filter. Gives the output of the vertical lines only. If I want a horizontal lines, I'll need a kernel of one one. I am just showing you what is the meaning of the kernel or the filter. When you apply this kind of filter, see, now we have a different image, same image, but we have highlighted the horizontal part of the image. Like there are blur kernel. So if we multiply with this kernel, it will blur the image. Let's say emboss the image. It highlights the and like 3D part of the image. It and creates a depth effect. Identity matrix shows a real image, so we don't need it. If you want to sharpen the image, you can see the image is sharpened here. This is a blur. You can see the difference in sharp image. So if we use this kernel, then becomes the sharp. So let's come back to the our part of machine learning. So we want, if we want to extract the feature, we don't know what part of the image is we want the ear or the nose part of the world, we don't know. And what will be the value of the kernel, we that even we don't know. So we feed these images into algorithm, and based on the our feedback, or say right answer, computer image will learn and learn the right kind of the kernel, and it will develop the kernel values. Mm, these are different kernel. If you want to see, I have attached the link for the edge detection, sharpen the image. Now you know, if you have the basic maths, if you know the basic maths, you can manipulate the images. We have this filter in our mobile camera, in selfie camera. So what happens in a convolutional neural network? So first we give an input. So we have given a task to computer that what is this, I have given you input this image, identify which number is this. So what will the computer do? He will apply the fiber kernel. We have to optimize, or we have to decide which kernel we want to apply, but the values will be identified by the neural network. So first we apply the convolution neural or kernel, then we apply max pooling, then again same thing, convolution neural network and max pooling. Then we flatten it, or say a fully connected network. Then we feed it to the machine learning part, and it gives us output. Let's say it has assumed that it is not 2 but it's 3. So we will show it right answer that it is not 3, it is a 2. Learn it, so it will learn from that it's the features of 3, not the 2. And then we provide the thousands of image with the right answer, it will learn from it. Let's visualize this convolution visual with the help of convolution visualizer. This is the kernel, and we input size we have the image, input image, the kernel below. This is the kernel. We can have padding. You can play with it after this session. This is another great visualization of the convolution neural network. What happens inside we don't know, but it will show us. Let's type here this number 5. So 5 will be printed here. For then we apply the convolution neural network multiple times, first, second, third, and so the computer will understand and evolve with this help of like this. It might get confused here, like it is a 3 or 5, you don't know. Then it goes max down sampling convolution. At last it will give us output of 5. Yes, here it has I cannot zoom the last part of it, but it shows the number value 5. It has identified it. This is another example of how convolution neural network looks like. Let's say this channel, first convolution neural network. So the value goes from these all values, kernel, the red, blue, and green channels, and then becomes this part. At last, it shows that the coffee is espresso. Now I have changed it to boat, so it has changed its answer boat. This is the inside part of the convolution neural network. We don't know what happened, but it tries multiple combination, and based on the real answer, it changes its answer and learn from it. So we use the word in the model. We are making the model with it, and we will use this model to in real life to guess the output. So I'll show you how it looks in real life in a Colab notebook with some code. So I have written down the code. First of all, we will be doing the classification with the help of TensorFlow. So as we import the TensorFlow and run it. These are the basic things, and I'm showing that it is easy to classify the images with the small neural network. Some of you might not be from the computer background or don't know the programming language. Say it's easy. We import this module. This module has some code that can identify the images, or this has predefined code. Then we import the data, train labels. Labels means answer, real answer, and this image will have some lots of images, like 50, 60,000 images, 6,000 images, 60,000 images, and 10 classes, 10 different classes. So with test image are the images that we will test the output, and this train image we will use to train our model. So we have downloaded it. And class names are aeroplane, automobile, birds, cat, deer, and truck. See here, we have visualized it. Now comes the part of the convolution neural network. So how we make a model? So model is what we have a sequence of layers. So first is convolution layer, then we use a max pooling layer, then we use flattening layer. So we define the model as a sequential, then we add a convolution layer, then max pooling, again convolution, again max pooling, and one convolution. This 5 line of code, and you have made the model out of it. Let's see, the model.summary shows us the summary of the model. First convolution, max pool, convolution, max pool, convolution. And these are the shape of the images: 30 by 30, 15 by 50, 13 by 13. Then we flatten it and dense it. We need the output of 10 class, so we dense it to the 10 class, not for the 64 class. We have the 64 pixel, but we want only 10 pixels because we have 10 output for the 10. We need 10 probabilities for each class. Then we compile and train the model. The model.compile and the fit model to our train images and train more labels. Epochs is what it will go through 10 times. All through all the as in our school, teacher taught us that read it 10 times. So epochs is number 10, means it will read the all data 10 times. It's showing error right now. Let me see. I have some error. I'm stop. 1 second. I'm canceling the sharing. If it still has the output.
That's okay, Colin. We can actually proceed if at all, we can give them an idea of, how we actually go about it. But we
Yes.
can proceed.
Yes, because I am using someone else PC, so it has no data. Even I have the offline data, but not right now. So no worries. So this is the basic procedure that the convolution layer, max pooling, convolution, and this
Can you share your desktop?
yes. Can you see my screen?
No.
Now?
Yeah, we can see your screen. Yeah.
Okay. So basically, the idea of this convolution neural network is learn from the image with the help of the maths. The convolution is the process that identify the features, and max pool the identify the real important features from the images. So if anybody has some questions, you can type in here, and I can answer your questions.
Yeah, we can take it at the end of the session. We can proceed with your presentation. We'll take it in the end.
I'm almost finished because I wanted to show this live demo, but no worries.
Okay, we'll take up the questions
Yes.
from the chat. We have a question from Shinoy asking
Okay.
how are large sized images processed?
As there is no barrier for the image size. We can put a filter before the starting of the convolution that each image have this input size of, let's say we want um, 256 by 256 image. Even if it's in a megapixel image, we can reduce the size. So it depends on the model, how have you made the model and what's the requirement of your model. Some models that automatically resize the input image, and some models don't accept it. So based on it, but image size is no barrier. The
Okay.
second question was how many times the iteration of the max pooling need to be performed. Again, I want to say that there is no rule. You have to experiment with your data, but you cannot do max pool and max pool. But the industrial standard or the standard procedure is like you use convolution error, then max pool, or if you don't want to use a max pool, use the average pool. uh, do average of the all numbers, for all 4 or 5 numbers, whatever your kernel size is, and then use it if you don't want to use max pool. Then the question is how the results are affected. Yes, the results are based on the applications. Like if I want to use my model is in a biomedical field, and one model is very good for the biomedical field, the same model won't work for the another. Like we want to identify the real objects on the road, at birds and rickshaws. These are the hyper parameter we have to tune before to implement in real life. We have to test it, and we have to see the accuracy. Then, so there is no hard and fast rule that the you have to use this many type of many times max pool, and you have to do this. And third question, what's the best resolution of the picture should be used? Will the grayscale image will be efficient in all cases? No, the grayscale will image won't be efficient in all cases. But most of the time what happens, we want to identify the objects. So in a grayscale image, even if it's a color image, some algorithm uses it as an input of the gray image, but it converts in a grayscale image based on the requirement. There are the many framework, VGG and the ResNet, and all. They have explained the how many number of times you have to do convolution layer, how many times you have to do a max pool layer. So they do research. Even if you want to implement in your field, you have to do research. You have to try and test how many times you and what type of neural network are you going to use. Will grayscale will be efficient? I have answered it. Yes. Heard about the OpenCV? Is it better than TensorFlow? OpenCV is like not we cannot depend on only on OpenCV. OpenCV obviously provides pre-trained models, but TensorFlow is you can customize it in your way. If you want to build your model, you will have a need of layers, your type of layer, your type of hyperparameter tuning. And TensorFlow and OpenCV is just playing with images. It works with the images. You can resize, you can read the images, even video, and you can apply some pre-trained algorithm also. So the OpenCV is like if you are newcomers in the field, you want to apply, so OpenCV will be easy for you. But if you want to develop your model, or say some another structures, the TensorFlow is there. And TensorFlow even can be applied from the natural language processing in all field. OpenCV is mostly related to the computer vision, CV for computer vision.
Yeah,
Any
Colin,
other
like,
question?
where all do you see these current applications on what industries are actually you think which will be looking at this current
Computer vision, yes.
yeah.
Yes, in every field, you see this application. Like we have in 200 years back when electricity was invented, we saw the electricity's application was in every industry. It reformed every industries. So the artificial intelligence and machine learning, deep learning field is implementing the every industry. Like if you have like I am working at the uh, 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 company that doctor only that provides the service of the doctors at home, like with the help of video call. But they want to we are implementing the artificial intelligence so that we can identify the features. So doctors don't have to identify the features, like the symptoms with the help of if the doctor have the data of the blood pressure with the help of some devices, so it can analyze it and predict the futures. Even the cancers can be identified in a sports field. Coaches uses the sport to this computer vision to identify the movement in let's take example of a football game, how player should move with the if efficient move. So they analyze this with the help of machine learning and deep learning. There
Thank
are
you.
many applications in industries like survey. If you I have seen the industry that implementing the if the workers have wore a helmet or not, to and if he hasn't wear the helmet, it will give a notice to him on his mobile. Yes,
Okay,
any.
okay,
Yes,
okay. Thank you, Colin.
yes,
I don't see any more questions for you right now. And uh, thanks everyone for joining us today. And we'll keep you posted for our upcoming webinars. Thank you, Colin, for taking your time out. And yeah, have a nice
yes,
day.
sure, sure. Bye.
Bye.
Thank you, everyone.